So we are set. So today Sam is going to, sorry about that. Sam is going to take us through starting a career in DevOps. And our quote for today is the best way to find out what you want in life is to try a lot of things. That's pretty self-explanatory. Um, the agenda for today is we are going to do an icebreaker, and then we are going to go through our meeting expectations. I'm going to talk about the community, and then Sam will take us through the session. So for our icebreaker today, and I want us to engage each other on the comment section, on the chat box. If you could live anywhere in the world for a year, where would it be? So I'll go first. If I'm to live anywhere for a year, it will probably be Switzerland because it has really good views and it's a pretty well developed country aside from the technology that it has. So for anyone who wants to tell us where they would want to live for, if they were to live for a year, where would they live? So Sam says he will live in Silicon Valley. Is that, oh, that's nice. Anyone else? Oh, Singapore from Isaac Ngeno. That's nice. Anyone else who would want to share where they would live for a year? Any place? Well, you can take it from like two more people and then we continue. Anyone who wants to share? Going once, going twice. Okay. So let's continue. So the rule is that you mute yourself when you're not speaking. And if you would want to speak, you just like raise your hand and then you'll be given a chance to speak. If you have any questions or you have something to comment on, you can use the chat box. Be respectful, be curious, come with the urge to learn. So about our community, our mission is to create a supportive and inclusive community that values diversity and supports learning and growth. Our vision is to be a leading DevOps community in Nairobi and beyond, which is, we are typically achieving that, and driving innovation and empowering professionals to excel in their careers. So part of our team, this part is not, we have grown and we need to update the team. We have a couple of people who have joined us in the community, but we have Samuel Kadima as our founder, Mamon Bonakombo as the director, Emma Gachoki as the assistant director, Masilin Mochama as the outreach manager. We have Samson as the programs lead. We have Ian as the finance manager. We have Alvin as the project lead. Myself as the event and the social media manager. We have Lawrence as the assistant event manager. We have Franklin Ode as the administrator. Daniel as the assistant creative manager, and Ivan as the assistant project lead. We have other people who are also leading in other sectors, and by the next meeting, the part will be updated. So if you want to help in our community, you can help us by running workshop and talks. So if you're good in a certain area and you'd want to have a session, you can just reach out to us and we'll definitely give you a slot. So you can connect us with DevOps professional. If you know anyone who their interest is in this area, you can connect us to them. and you can definitely give us feedback, which really helps us to grow. If you have any ideas to make the community better, you can as well share it with us. And you can also help us by posting and reposting on like social media. And then if you are good with like documenting and you'd want to share, it will really help other people in the community. Also, we have a couple of events. So if you are really an organizing person, you can help us with organizing the events. So if you want to join our community, you can scan the QR codes on the screen to join different channels. And as maybe that will be up for a while, we have a couple of things planned for this year. We are really excited, and we are really looking forward to what the year has. Sorry about that, in store for us. So we have DevOps Days, which is coming pretty soon. It will be on 1st of June. And we are really looking forward to it because it will be a really, really big event. We also have the Africa DevOps Summit, which we are planning to have it by the end of the year. And then we have a couple of other collaborations and things that we are also planning. And we are also looking forward to it. We have lots and lots and lots of Twitter sessions that we are going to have for the rest of the year. So if you'd want to participate or be a speaker in one of the Twitter sessions, you can reach out to me and then we can plan on it. So today we are going to go through getting started with DevOps engineering, and Samuel Kadima will take us through that. I hope you enjoy the session, and if you have any questions, you can ask. And yeah, let's see what we are going to learn today. So, Sam, you are welcome.
Thank you very much. So I believe most of the people, maybe they're not able to chat because they are viewers automatically. So we made people viewers because previously we had people spamming us while we were having our session. So in case you want to comment or to talk, you can just raise your hand and you'll be given the opportunity to do that. So yeah. So I hope with that being said, I can share my slides and we can be able to continue. So let me share my slides. Ivy, I hope you can hear me clearly.
Yes, I can hear you.
Okay, good. So this is a session that I would like it to be interactive. I'd like you guys to contribute to the session as I ask questions, and that way it will be more fun. So my name is Samuel Kadima. I'm a DevOps engineer, and I teach DevOps at Moringa School. So I'm happy to see you guys in this meeting. And I hope that by the end of the meeting, you'll have learned something that can help you in your career as you get started in DevOps. So on our agenda, what you're going to look at, the first thing is just an introduction to DevOps engineering. And then we are going to look at some of the tools that are there that are used for DevOps. And then we look at the DevOps roadmap. And then after that, we are going to look at the DevOps careers. And then after that, of course, we are going to allow you guys to ask questions and I'll be able to respond to them. So in case you have a question at any point, you can feel free to raise your hand and I'll be able to respond. Or you can also hold on to the question and ask it at the end. So, but it will be an interactive session, and I look forward to it being an interactive session. So to get us started, the first thing is for us to understand what DevOps is. So is there anyone in the meeting who has an idea of what DevOps could be? Anyone who has interacted with DevOps? Is there anyone who has heard about DevOps? You can just raise your hand. I hope that you are able to raise your hand. Is that possible? So I think Joseph Waweru, so let me allow you to speak. Yeah, so you can go ahead, Joseph. Joseph, you should be able to speak. You can unmute and speak. Also, you wanted to comment. So Joseph says breaking silos between development and so let me read the entire comment. Development and operation teams. Thank you for sharing, Joseph. Is there anyone else who has an idea of what DevOps could be? You can just share what you have heard or what you think. It doesn't have to be correct. Any information or anything you've heard about DevOps, you can share that. You can just raise your hand, give you the chance. Okay, good. So I think we'll just go with what DevOps, with what Joseph has said. So DevOps is just a combination of people, practices, and tools that enhance the speed at which software is delivered to users. So the users of software are just people like you and me, and we visit, let's say, websites, and we want to use websites, and while we are using the websites, we want to have a good experience. So you do not want, when you are visiting, let's say, a website, or you're using an application like M-Pesa, for example, you do not want it to fail. You want it to always work as expected. So for you to have that good experience, so we have DevOps working in the background to ensure that you can always have that good experience. And how it does that is by ensuring that uh, there is some culture that is set in place together with tools and practices that allow the software to be of good quality by the time you are using that software. So some of these things may be, so in the DevOps lifecycle, we start with planning. So as you can see on the image on this other side here, so you can start by planning. So you plan, and then after planning, you can go ahead and code. So after coding, maybe you need to integrate your code with to do CI/CD, continuous integration, and continuous integration, where you're going to test your code, and also maybe integrate some communication there, so that in case something fails, it gets tested first, and then it doesn't have to be the user of the software who is using the software and it's failing in their hands. So you ensure as DevOps engineers, DevOps engineers, what they do basically is just to ensure that this software can at least fail first before it gets to the user. So how do they do that is by now this CI/CD that they implement there, to ensure that they can be able to test this code automatically, and if it fails, the people responsible can be notified. So they may integrate some tools for communication, so that this can be able to, so that this is possible, so that uh, the software can fail in advance, and they can be aware of it and solve it before it goes to production. So what normally happens, we also have things called pipelines that are created. So like different steps. So software will go through different stages before it even arrives where it's supposed to be used. So there is a pipeline that is going to be created by a DevOps engineer, or some steps that need to be approved before the software arrives where it's supposed to be used. So what normally happens, the first part may be testing the code, for example, to ensure that it works as expected. So once it has been that has been done, it goes ahead to the next stage, and there are more things that are going to be tested to ensure that both the small bits of the code that has been written by software developers to the maybe how they've packaged it, if they've used dependencies, you are testing all those things to ensure that your code works as expected. So the word DevOps is a word that was derived at by taking development and operations, and then so from development and operations, we get the short forms of dev and ops, and then we brought them together. So why do we have this? Why do we have? Why do you think it's necessary for us to have these two teams, or this? Why do we need to have a DevOps engineer? So because you are just having a developer, let's say in the past we used to have a developer or development teams, and we had operation teams. So now we are saying that we need DevOps engineers. Yet, if we had two people in development, one of them, we had another one in operation. They were working, they were deploying software. So what is the challenge, or why did DevOps come up? So what happened in the past is there used to be separate teams, like so you have separate development teams, you have operation teams, and so this posed some challenges because the developers always are developing new features. So developers will always be developing new features, and as they're developing new features, they want to see these features deployed. So developers capitalize on agility, and once they've developed software in the past, what used to happen is they give that software to the operations team. So the operations team are responsible for where the software is running and ensuring that software is running as expected on that end. So while these two teams are separated like that, so the developers do not know anything about what is going on in production because their work ended at development, they gave it to production. So in case there is any issue that probably the developers needed to act on, that information is not getting to developers in time. So there is a communication barrier. And then there is also a conflict because the developers are giving too much features to the development team, to the operations team, but the operations team knows that every time they introduce a new feature in production, there is high chance or increased scope for vulnerability or for some features to fail when they're integrating the new features that you want to release into the production software that is already working. There is a chance that some things may break. So the production people were so hesitant in making the decision on whether to release new features. As developers team keep on pushing new features to them, they do not want to deploy because they want to retain the stable version that is currently deployed in production. So they do not want to introduce something new that may introduce some bugs and make the system to fail. So that posed as a challenge. It caused conflicts. So the solution to this is, and apart from causing conflicts, it slowed down the release of software. So there are new features that need to be deployed, but they are being slowed down because these people in production want to ensure that software is not introduced, new features are not introduced so that the software is stable. So DevOps comes in between to solve this problem. So the problem that DevOps solves is ensuring that it's possible for this for both development and operations, first of all, to be aware of what is going on, even in production, the people in software development can be aware of what is going on. In case there is a failure somewhere, the people can be aware. So with DevOps, you normally integrate communication tools like Slack, like Microsoft Teams. So people who are working in a DevOps team can be able to see where there is a failure, and they can be able to work on it, act on it. So in the DevOps, so in DevOps, we said we start with planning. So after planning, you go to development. So planning, here you're using tools like Jira, Trello. So you are going to plan. So you plan on how you are, what you are going to do, and some features that you need. So you create, let's say you create a backlog of the things that you need to do, and then you go ahead and you start working. You create the features, and as you do that, so DevOps allows you to push. You can create a feature today and push it to production because everything is automated. So DevOps engineers automate the process of software delivery. So instead of doing it manually, or where we need to once we are done with software, we give it to other people and then they push it. So we can continually do that because DevOps have allowed, using tools, DevOps engineers have allowed us to automate. They've set up a system that software developers can just push their code, and the moment they push that, the other steps take place. So it's possible for software to get tested, and if the software is working as expected, it can integrate with any other things that it requires, and it can go through all the steps that are required, and it can be able to be deployed if it meets all the standards, or if it's able to go through the entire pipeline successfully, it can be deployed. So DevOps, with this now, it makes it possible for software to be delivered faster and also for software to fail fast. So when software fails fast, uh, it is possible for you to solve the problem before it gets to the user, because amongst the first things that you're going to do is to ensure that you are testing that the software works as expected before it goes to production. So the users will always have a good experience when they're using your software. And because now you can be able to push small features into production at every point, it implies that you'll always be getting feedback. So you are getting feedback, you can improve on your software and get better software quality. So your users will end up getting better software. So in real time. So uh, that is maybe an overview of maybe what DevOps is and how it works. So in case anyone has a question so far about that, maybe you can raise your hand and then we'll proceed from there. Is there anyone with a question? Anyone with a question? Yes, Sheila, can go ahead. Sheila, I believe should be able to speak now.
Hello, hi Sam, can you hear me?
Hello, I can hear you.
Yes, so you've described the role of a DevOps engineer, but it's a bit confusing. How is that different from let's say a software engineer in test? So,
From a software engineer.
in test,
So, so what? So me, I don't know if what a software engineer in test does, but I know what a software engineer does. Maybe you can enlighten me on what a software engineer in test does.
okay, from what I've heard from some of my friends in that role, what they do is so whenever maybe applications are running in the organization and they're about to introduce maybe new features, they have to run tests on them before it goes to production. Are they to some extent also DevOps engineers?
So DevOps engineers, what they do. So probably software engineers in test are similar to QA engineers.
Yes.
Yeah. So yeah, so DevOps engineers, their work is just to automate the process of software delivery. So what they do is they work with different tools. So there are different tools that they incorporate, which we are going to look at, and their work is shortening the process of software delivery and ensure that quality software is delivered to users. So testing is just one of the things that they do, but there are many things that they do. So I was just using testing, for example, just to ensure that software is quality before it goes to production. But they need also to package that software to ensure that it is in the right state. For example, they'll ensure they're containerizing. They need to build images. They need to containerize the software, and they're also aware of the environment of where the software is going to run. So they're able to deploy it and set up maybe some networking and be able to deploy it in the right places. Does that make sense?
Yes, thank you.
Okay, is there anyone else with a question? Anyone else who did not make sense of that? Okay, good. So I think I will proceed at this point if there is no one else with a question. So some of the DevOps tools. So many people fear DevOps because of the many tools. So we have many tools in DevOps, but you may not need to use all tools at a go. So you just need to specialize in specific tools, because in every DevOps implementation, you may need just a specific number of tools. So there are some tools that substitute each other, and you may not need them always. So for example, DevOps. So for DevOps is works in a distributed technology. So you may find that you may need to manage many things at a go. So in order for you to have what you said, the main point is for users to have the best experience while they're using software. So for you to be able to achieve that, you have to ensure that maybe one of the things you have to ensure you have redundant software. So in case software fails in one area, there is backup that can run in place of that. Or in case maybe there is high demand for your services, let's say there is more people requesting for services, you need to scale. So you have different tools that can allow you to do that. You may be working with many servers, you may be working with containers, many containers that are packaging your code. And that's, let's say, just having several copies of your applications, of your single application. It has several copies, and you are deploying it in different servers. So you need to manage that. So you need to monitor, you need to ensure there is networking, you need to ensure that these things are healthy and such things. So these tools, you have many tools that are going to help you to do that. And you also have the cloud. So the cloud, of course, you may be using all major clouds, but you can achieve everything through one cloud. So you don't have to learn every cloud. So if it's, for example, if you're learning, let's say you're learning CI/CD, there are several tools for CI/CD. So as you can see on this image, you have maybe you have Jenkins, maybe you have GitHub Actions, maybe you have GitLab. So you have many tools that can be used, but you may need maybe just one tool, depending on what you are, depending on the company. The company may be using a specific tool, and then let's say for let's say another tool, let's say like for infrastructure as code, you have Terraform, you have Ansible, and you have more tools. So for every stack, there are many things that you can use. Even if you have to integrate communication, you can say you're going to integrate with Slack or integrate with Microsoft Teams. So it's just a choice that you're going to make. So even though there are many tools, the basics are the same, and you'll be able to use the tools. Once you learn one tool, you can be able to replicate that and learn any other tool when there is need for you to do that. So, what is the DevOps roadmap. So I'll be talking about, when I'm talking about the roadmap, I'll be talking about the specific tools that you may be interacting with at a specific place. So the first thing that you are going to learn as a DevOps engineer. So I start with Linux here at the top. I prioritize it because I know if you're going to install Linux, you have to start by knowing how to use Linux and know how it works before you go to any other thing. But it doesn't mean that it is, if you already know something else, let's say you're already a software engineer, it doesn't mean that you started in the wrong way. So you have to unlearn and go to Linux first. So you have to, with what you have, you can look at this and see what you need to upgrade on. But if you are new, let's say you're using Windows right now. So the reason why I would recommend Linux administration is because first of all, most servers that you're going to deploy your code to are have Linux operating system running on them. So that is why it is recommended that you use Linux while learning DevOps. So use Linux operating system. So for Linux, what you need to know is, of course, how to administer Linux. So you need to know how to administer, to set up, to manage users. You need to know how to use the command line. You need to know how to administer networking. You also need to know bash scripting, and you also need to know virtualization. So you should be able to manage several Linux machines, and that is now a distributed system. You should not be able to create virtual machines and virtualize and understand how virtualization works. So that is the part for Linux. And you also, after you've done that, you can go ahead and learn about networking. So networking is important because I've said you're working in a distributed system. So in a distributed system, every distributed system, you have several computers that are distributed. So how are these computers going to communicate? So different servers that need to communicate. So you need to understand networking. How are these things communicated? Which protocols are they using? So you need to understand, of course, first thing that you need to understand about networking is OSI model, because that guides how everything communicates. So you need to understand that, and then you can understand TCP/IP, and then understand the basics. So like IP addressing, understand subnetting, because you're going to, when you're working with networks, you're going to be able, you should be able to understand what is going on. Maybe you need to create more networks and such things. And then you also need to understand network troubleshooting, so that you can be able to troubleshoot when there is an issue in your distributed system. And then, of course, we say DevOps is dependent on development and operations. So for development part, you are talking about software. So software implies that you need to understand software. How is software created? You should be able to create software, and you should know how to package that software. So that is software engineering. You add on top of that. And I believe the top three that I've just mentioned, that is Linux administration, networking, and software engineering. Those are the basics. So with that, once you have those at your fingertips, everything else will be very easy, because every other thing is dependent on these three. So if you go and learn any other tool that you're going to learn in DevOps, it's these tools are mostly dependent on under the hood. There is networking that you need to understand. There is some administration you need to operate on the terminal, and you need to be able to manage something or send something, some information, writing commands through the terminal. You need to understand how things work. You need maybe to create some text files and such things. You need to understand how you can use that. So in the part of Linux administration, you also need to understand either Nano or Vim that you can use to write your text, and also the file system, of course, for the Linux file system. So you should know how that works, and storage as well. So with those basics, you can go ahead and learn infrastructure as code. So infrastructure as code, so you already know virtualization. Virtualization maybe has enabled you to create several servers on your computer. Your one computer, but you've been able to create some virtual machines. So you can go ahead and now manage machines that are remote, not on your computer. You have several machines that maybe are on AWS or Google Cloud or Azure. So you use infrastructure as code, where you just write code, and this code is going to be used to set up infrastructure for you, or configure infrastructure. So some of the tools that we use here, we have Terraform, which can allow you to set up the infrastructure, and then you have Ansible, Chef, Puppet, which can allow you to, and Puppet that can allow you to configure infrastructure. So those are just some of the examples. And then we have CI/CD. So infrastructure, when I'm talking about infrastructure, I'm talking about when you're interacting with remote environments, let's say in the cloud, you want to go and set up a virtual machine, you want to set up some network, that is the infrastructure that you are setting up. And then you need to install some things. Then at that point, you're configuring some things. So you need to use things, that is why you use Ansible, you use Terraform, you use Chef, you use Puppet, and then you have CI/CD. So CI/CD is continuous integration and continuous delivery, or continuous integration and continuous deployment. So for CI/CD, this is where you do your integration and delivery. So you're going to create pipelines. So these pipelines just contain steps. So let's say the word pipe, what is on the pipeline? It's like the way water enters a pipe and it leaves on the other side. So when it gets into the pipe, what does it encounter first? Does the pipe have a bend? Should it go through several bends before it arrives? And if it successfully goes through all bends, it's going to arrive where you can be able to fetch it and drink it. So for software, the same. So you create a pipeline. So you have we have two pipelines that you can create. So you can have a pipeline that you can create on the integration side, and you can also have a delivery or a release pipeline that can release your software. So you use tools like Jenkins, you use GitHub Actions, you use what else do you use here? So those are there are more tools. I think they have run out of my mind. You can use GitLab. So those are some of the tools. So you can just learn about more tools. And then we have containerization. So after that, you can, so for CI/CD, you have your software, you know how to create software. Now you are able to do maybe CI/CD and just know different steps that need to be taken so that this software is quality by the time it's delivered. So the other thing you need to understand is containerization. So containerization allows you to package this software with or code together with dependencies, so that it can run on because you're not it can run on any server, and it will not have any issues on that server, maybe because some things it requires are not installed on that server, or there's some conflicting dependencies on or libraries in that server. So containerization allows you to isolate uh, your application and everything it requires from where it's going to run, so that the container can run there and your application will be shielded from that environment, so that it can run always in the state that you desired it to run. So here, the technology that is famous and that is used mostly is Docker. So that is what I will recommend you to go and learn. And then, of course, after that, you can learn orchestration. So orchestration is just where you can write what you desire in files, YAML files. You just write what you desire on how your software should be managed while it's running. So since you're going to run your software in a distributed system, so how should your software scale? How should your software be managed? while it's in production without you having to be there. So you just create like a plan of what needs to be done. So, and then that is going to be actualized when the software is deployed in production. So the tool that is used for orchestration nowadays is Kubernetes, but you can also use Docker Swarm, which was mostly used in the past. So, but Kubernetes is the right tool for you to learn at this current age. So when you are learning Docker, probably you learn a little bit about Docker Swarm, but just that is just for knowledge purposes. Just capitalize on Kubernetes, and then you have, of course, we said the first step is planning, and then you create software, and then after you create software, probably you need to test that software, verify the software quality, and then package that software and deploy it. Once you deploy the software, the next thing is to monitor, because you always do not want at any point things to fail when you are not aware. So you want to be aware of when things are not going as expected. So when you're in the monitoring phase, what normally happens, you create alerts so that when your software is being running in production, we've said the main goal is to ensure that at no point the user experiences a shortage or has a bad experience. So let's say there is an instance where your software, you deployed it to some servers, but the compute resources are getting depleted. So in such a situation, you need to ensure that you provide more resources, but you do not want to wait until there are no longer any more resources to sustain your software because of the amount of maybe compute power it requires, maybe RAM or storage or anything of the sort. So you can monitor this and say, maybe when I get to this percentage of utilization of my resources, then I should be able to get an alert so that I can know there is a spike in the demand, so that I can be able to act accordingly and maybe scale scale in advance. So scale in advance or do something, make some decisions, because of even though you have said you're working in a distributed system, of course you do not want just to go and allow your application to just scale to infinity without your knowledge. So because you're going to pay for the extra, let's say, for example, computing power that you need, if you just take all the computing power, it's going to be expensive for you. So you can just limit what you are going to use, but you monitor so that you do not incur too much cost when your applications are running. So you monitor, you create alerts, and through that, you're able to maintain your software in advance in the right state. So here you can use tools like Prometheus, you can use Grafana, you can, in the cloud, you have different cloud providers, and each of them have monitoring tools that can allow you to monitor your applications or your infrastructure where your software is running from. And you can be able to act accordingly in advance before your application is no longer, before you get to a situation where users experience an outage. Yeah. So that is very important for you to implement this monitoring. And we also have logging tools like FluentD that can allow you to check how you are, maybe in case there is you need to troubleshoot, you can be able to collect these logs and they can help you in identifying where the problem is. So we have, apart from monitoring and logging, we have collaboration and communication. So there I've talked about, for collaboration, is where we have tools like Jira and Trello, Kanban. So that is where you learn how to plan. So for collaboration, there you can plan, and you can also use tools like GitHub for collaboration. For collaboration, you can use for communication. You can use things like Slack and Microsoft Teams. So in software engineering, what I didn't mention, so you're not just learning how to code, you're also learning about where that software, how you can work with other developers. So you're going to learn Git as well when you're working with software engineering. In the software engineering phase, you're going to maybe learn more about Git and GitHub as well. So, and then after you've done that, the next thing that you need to do is now create some hands-on projects and do some certifications. So there are many certifications: DevOps certification, Cloud Architect certifications. Those are the ones, or even Kubernetes, Linux administration, networking certifications. So after you have some skill, you can now go ahead and do these certifications. So some of the careers that you can do as a DevOps engineer, of course, the first one is a DevOps engineer. So you can work in a company and help them in ensuring that there is a flawless process of delivering software by setting up tools and infrastructure, automating that so that it's possible for them to deliver software faster to their clients. And then you can also be a DevOps consultant. Of course, companies can consult you. And then you have DevOps technical trainer like me, so you can teach people DevOps. And then you have a release manager. So you're just responsible for the deployment of the software and ensuring that you're delivering software quality. And then you have DevOps evangelist, who is like a DevOps manager. And then you also have a DevOps architect, who is similar to a cloud architect. So we say that this DevOps engineer needs to worry about, they may be managing servers. They need to set up servers, set up infrastructure and such things. So for you to set up infrastructure, you need to be aware of the infrastructure. So if you're not aware of the infrastructure, so that is why maybe you need to be an architect. It's a DevOps engineer it may be good for you to also be an architect, because you can think about which kind of technology will be the best for me to be able to deliver the best for my clients. So if you are going to deliver, let's say there are some cases where you're going to containerize your application. There are some cases maybe you don't know, containerization may not be the best thing to do for something or for some task, or which networks are you going to put or something of the sort. So you're going to think about that before you go ahead and just implement that. So you have to think about it, and you have to plan for the infrastructure where your application is going to run. So another role that you can have is SRE, which is Site Reliability Engineer. And this is where monitoring comes in handy. So you can be able to monitor your software running in production, and you can be able to solve that the problem. So as an SRE engineer, you're also going to be automating a lot of things, and you're also going to be, you should be having software engineering skills for you to be able to perform well in that role. So those are some of the careers. There may be more careers that I've missed. And at this point, I will welcome questions from you guys. So if you have a question, just feel free to raise your hand, and I'm going to give you a chance. So anyone with a question? Kiprono. So let me see if you have access. Keep your hand up, please, so that I can be able to allow you to speak. Go ahead, Kiprono. Kiprono and then Kevin. So we start with Kiprono. You can unmute and speak.
Thank you, Sam, for the good session that we've had so far. I have 3 questions.
Okay.
One is on software engineering. So what is the minimum that someone must have so that they are able to start up on DevOps engineering? And then
in terms of software engineering?
Yes. Like okay. How much should they know? What is the minimum?
Okay.
And then on the CI/CD, are we building continuous integration pipeline separately from the continuous delivery or continuous deployment? And then also there's that thin line between continuous delivery and continuous deployment. Could you mention a little bit on that?
Okay.
And then on monitoring and logging, I've just been wondering, like, what exactly are we monitoring and what exactly are we logging?
Okay, that
Especially
is. Oh, okay.
on logging. I want to know clearly what are we logging.
Okay. So I think your questions are many. So let me start, but in case I forget to answer any, you'll just remind me.
Okay, okay, sure.
So for software engineering, what you need to understand, of course, you need to understand the software architecture. So when you're creating software, software has a, let's say, front end. You have a front end, you have a back end. So how does this connect? Which how can you create a front end, and how is it possible for you maybe to visit, for example, from the front end? I can visit this URL, I get this, I can be able to do this. How does it work? So you need to understand that, and then understand how to create a front end part, the front end part of an application. Understand how to integrate it with the backend. So you use APIs. They're called application programming interfaces. How can you integrate that? So in the front end, you have some frameworks. You can learn the basics like HTML, CSS, and JavaScript, and then learn a framework. So once you have done that, you have frameworks like Vue.js. We have Angular. We have React.js. So you can learn one of the frameworks after you've learned the basics, that is HTML, CSS, and JavaScript. And then once you've done that, you can go ahead and learn about backend development. So backend development, you need to learn a language. So you can decide, if you decide to go with JavaScript, you can go ahead and learn Node.js. But for automating tasks, what is recommended in DevOps is Python. So I would recommend, even though you've learned maybe in the front end JavaScript, I would recommend you go and learn Python in the back end so that you can be conversant with Python. So Python, you can go ahead and, so if you are going to use, before you go to Python, if you're going to use JavaScript, maybe you learn Node and Express. But if you're going to use Python, you can learn Python, learn Flask and Django, or Flask, either Flask or Django. But it's recommended that you can just learn one, and after you learn Python, go and learn Flask to understand the basics, and then you go ahead and learn Django, which is easier to use. And then, of course, before you learn Flask and Django are frameworks, so you need to understand programming first, how the language that is used in those frameworks, which is Python. So you can learn Python, and as you're learning Python, ensure you also understand object-oriented programming. And then you need to understand databases. How can you interact with the database? How can you create a database? How can you design the database? So you need to understand that part, and how that connects with your API, and how that API connects with your front end. So that is basically software. And also you should be able to push to GitHub. You should be able to understand version control. Yeah. So that is the main thing I would say about software. So I believe that answers that question. Are you satisfied about that?
Yeah, but also maybe we could speak on someone who's doing Android or iOS for mobile developers.
So let's say you are doing Android. So for Android, there is no specific language for backend. It's just for Android is for front end. Your application is like, let's say, once you understand XML and you understand Java or Kotlin, that is the front end, isn't it? So you still have the liberty, if you instead of maybe learning a front end, maybe using React or for websites, if you know Android, you need to understand backend now. So go and learn. You can use Python there and Django for you to create a backend of a system. Or if you do not want to run this, you can go ahead and maybe use Java and Spring Boot or Java and Spark to create the backend of an API. But for the database, the database are just the same ones. So you can either learn PostgreSQL, you can run MySQL, and you'll be fine. So you can utilize that in any language. But if you are, so for Android or for web, the only difference is the front end part of the application. So the Android part is just what people are going to interact with on the front end, on their phones, on their, or on the website. But there is a backend that this Android is going to interact with. So ensure you understand both backend, even if you are on Android. So if you are on Android, you don't have to go ahead again and learn websites, how to create websites. You'll still learn. If you are using Android, you'll still be able to understand the front end part, and then you integrate with backend. Does that make sense?
Yeah, sure. Again, I'll be very curious to understand how to containerize maybe an Android application, considering that you have the UI using XML and Jetpack Compose maybe, and then the backend on Kotlin, the logic side, Kotlin or Java, and also that aspect of having maybe APIs using other languages, maybe not Django. So maybe if you'd in future consider taking us through containerization for mobile applications, I'll be very glad.
Okay. Thank you. So we'll work on that. So what was your other question? Oh, I think about monitoring. You asked about what exactly are we monitoring. So we said one of the things you need to monitor is I gave an example. Let's say you deploy your application, and you say this application requires I'm going to give it some CPU resource and focus of CPU. I'm going to give it, it's going to run on, let's say 16 GB RAM. This, I'm creating a virtual machine where my application is going to run. It's going to have 16 GB RAM, and it's going to also have something like, let's say 500 GB hard disk or SSD. And then it's just a simple website for your startup that you do not expect many people to sign up. But after you set up the system, you realize that there are more requests that are coming in. So how will you be able to know that there are more requests, first of all, for you to act? Because you are saying that in case these requests continue increasing in number, at the end of the day, your server is going to fail, or people are not going to be able to send successful requests. If they're trying to reach your server, it will be overloaded, and it's not going to be responsive. So you need to monitor and see. For example, if your application is running, is this application utilizing too much CPU, for example, while it's running, while it's processing some things? So if you monitor CPU, you'll be able to collect some metrics, and you can make a decision on that. You can say there is a increase in utilization of CPU. Probably I need to increase the CPU capacity. So if, for example, you need to, so you'll make a decision on whether to scale or something of the sort. So that is one of the things that you're going to monitor. And in case somebody sent something and it failed, there is an error, they got an error or something. So you're monitoring. If there is something that failed, you want to collect some logs and be able to see, to be able to solve the problem. So the logs will help you know exactly where the problem is so that you can act on it. So monitoring will allow you to get a notification, to know where there is an issue, and you use the logs to come to a conclusion on where the problem is. So if you may not know, let's say if your application is slow, people are sending requests and they are not getting responses, you may not just say without any data that the latency is because of the CPU. So you have to go and check, is it the CPU that has issues, or is it any other thing? So you are going to check the logs and see if there is an issue with the CPU or elsewhere. So that is the usefulness of monitoring and logging. Does that make sense?
Yeah, very, very clear.
Yeah. So have I answered all your questions?
Not really. There's one for the CI/CD pipelines. I wanted to know, is it that you build a continuous integration pipeline separately and also build a continuous delivery separately? And then the difference between continuous delivery and continuous deployment. Yeah.
Okay. So I believe that you can even search what is the difference between continuous delivery and deployment. So what I'll say about the pipeline is you want always to have specific if you want to have separation of concerns. So if it's there is of course you can have one pipeline for everything. There is no limit. It will not have any negative impact. But you just want to ensure that you are treating things differently based on what they do. So if a CI pipeline, a continuous integration pipeline, is not working as expected, it fails, and you've separated them, you'll just know the delivery pipeline has never been triggered. So it's just a different pipeline. So it's a good way of doing it, but it doesn't mean that, of course, even in a single pipeline, it will fail and the rest of the things in the pipeline steps will not be executed. But it's just a good thing for you to separate the two. So for continuous delivery and continuous deployment. So for continuous delivery is whereby you have your software and I have to confirm that. So one of them, between continuous and the deployment and delivery, there is one that somebody has to approve. So I believe that could be continuous deployment. So, and then continuous delivery, everything is automated and there should be no intermediary at the end to be able to maybe to press a button for the software to go into production. So it can automatically go into production. So, yes.
I think that is very clear.
Okay, good. So is there any, I think there was somebody else with a question. Kevin.
Yes, thank you so much, Samuel, for even such a insightful session. Mine is I'm an upcoming DevOps engineer. So one of the questions that I usually get from most people is about practical experience that I've gained over the time. I've tried working on personal projects. So do you know some platforms where I can even get more practical experience working with some of these DevOps tools or communities, and how basically a place to actually get a real world practical experience that I can work with, or even places that take maybe junior DevOps engineers to kickstart that DevOps engineer journey.
Okay. So I think one of the platforms I know is called Cloud, so that you can do some projects there. I personally have not used it, but I've just been hearing people who are using it. So you can check it out and see what you can do there. And then I do not yet know about where people can maybe get experience from, but I would advise maybe trying to find a company that does not have a software engineer, or even volunteering in a company that exists and trying to implement DevOps for them part-time. So just to gain experience, the company that has not implemented DevOps, you try to do it for them. So you can find such and try, and just apply for internships. So you can just turn an alert on LinkedIn and see when opportunities are there. You apply for them. That is what I can advise. But if there is anyone else who has an idea of what where experience can be, where someone can get experience, you can share as well.
Okay, thank you so much, Samuel. You can also type, there's a name you put on the, you said, I don't know, cloud. Maybe you can put it on the chat for me
Code
to
Cloud.
put it.
Okay.
Or code cloud.
So yeah, so if you can, I see your hand is up.
I don't know, Sam, if there's anyone who wants to use the comment section, you can raise your hand so that you can be allowed, because I'm pretty sure there's someone who wants to use the comment section and maybe they don't want to talk on like mic.
Okay. So you can just raise your hand. So I think the next person that you're going to hear from is, let's hear from Barbara. Hello, Barbara. You wanted to try it on the chat? So let me see what you are writing here. So Moses says AWS has a forever free tier. It's is it a forever or 1 year free tier? And then it's a great way to get started with so you can be able to access. So you have on these most cloud providers, you have some either credits that can allow you to get started or a free tier. So I believe AWS has 1 year free tier that you can use for learning. So in case you want to learn about anything about the cloud, you can use it to learn. And also maybe when you are creating your virtual machines, you're creating all these things that you need to manage using DevOps tools, you can create them on these platforms on the cloud. So Ivy says AWS has a Twitch session on cloud and DevOps. And then, so Barbara, did you want to say anything? I saw your hands up. I've allowed you to speak, so you can just speak. Go ahead and unmute. You can unmute and talk.
Hi,
Hi, how are you?
I'm fine. I wanted to ask whether when I want to do the DevOps career, if itakuwa lazima nikuwe nimesoma Linux administration, networking, and software engineering ndo I do it. Yeah.
So if you are considering a DevOps career, it means you are not conversant with any DevOps probably. So you start anywhere. So there is no, you don't have to have skills. Because everything I've mentioned there are things that you can learn from scratch. You just start with one, you learn it first, and then you go to the next one. So you don't have to have any experience when you're starting to learn DevOps. You only need experience for you to become a DevOps engineer. But when you're learning, you can start with zero knowledge, zero experience. You just start. You learn Linux, you learn networking, you learn software development, and then you go ahead and learn all the other things that you need to learn on the way. Does that make sense?
Yeah, it does. So that means that in that course, they'll teach us those things.
So depending on where you are applying for the course, you just need to look at the structure of what they're teaching.
Okay, thank you.
You're welcome. Chacha, go ahead.
Hello, everyone.
Hello.
I unfortunately I joined a little late. Nilikuwa nadhani inaanza 9. I forgot kuangalia mail, but no worries. There's a question yenye ilikuwa imeulizwa, I think by the first person who asked the question ya ku-automate deployment for mobile applications. Usually, mobile application, for example, Android as a case in point, there's no point here to build an image for it or something. What you do is you simulate, you create an environment kutumia platform kama GitHub ama kama unatumia GitLab, you can create an environment kama yenye iko kwa your machine, and then you can have a pipeline that runs kwa hiyo environment, and then it does the deployments for you. So you build, unaandika tu code yako and then you push, and then kama kwa GitLab, mimi nimetumia GitLab sana. You can set up a runner, inachukua code yako, ina run some Gradle commands kama Gradle test ama Gradle bundle. Kama uko na unit tests zenye umeandika, unaweza run tests, and then inaweza bundle, and then ita generate the AAB, and then there's a tool called Fastlane yenye unaweza tumia kupublish to end. So unajenga tu code, una push kwa GitLab ama kwa GitHub, and then our pipeline runs in a test, in a bundle the application, and then the final bundle upload kwa Play Store. Kama ni iOS application, na upload kwa App Store. So there's an amazing tool called Fastlane for automating mobile applications. So the person mwenye alikuwa anaulizia automate mobile application, you can check out Fastlane. Iko na documentation nzuri tu, utapotea.
Okay.
Thank you, Sam.
Thank you so much for sharing. So is there anyone else? Anyone else? So if there is none, is there anything on the chat? I don't think so. So back to you, Ivy, then. Thank you guys for the session. Yes, Kiprono?
I was thinking something on caching. Are we able to cache a pipeline?
To cache a pipeline. So I do not think that you should cache a pipeline, because if you do that, it means some steps will not be executed. Because you need things to be run every time afresh, so that you can be able to catch in case there is anything that is not working as expected every time. You catch that, and you are able to alert in case it does not work or it fails at that point. Moses?
Yes, I was actually going to try and help and answer that question. So the answer is it's twofold. There's yes and no. So you can cache the assets that are generated from a pipeline. So for example, if you're deploying, for example, a Node.js application, sometimes you want to cache the dependencies that are not changing. So the node dependencies that are not changing. So if you're doing a very fast CI process, every time you update your code, but your node version is not changing, your basic dependencies are not changing, you can cache those. So what you do in your pipeline is you look out for changes in that cache with the cache keys, and if the dependencies have changed, then you reload your dependencies, and then you run them through. So that's actually a really good practice, because it reduces the time of your pipelines, reduces your cost if you're using GitHub Actions or GitLab, and storage cost, because you always have the caches there. So you always want to cache the dependencies that don't change. But the pieces of your code that are your self dependencies, let's say, for example, you've built your own assets, you've built your own libraries that you change when you're deploying your app, you don't want to cache those. So it's a yes and no. So look for the things that don't change, cache those.
Okay.
And always make sure that you don't cache your code. So
okay. Yeah. Okay, thank you so much, Moses, for that enlightenment. So is there anyone else with a question before I give it back to Ivy? Okay, so thank you guys for listening to me. So in case you want to interact with me, you can find me on LinkedIn. My name is Samuel Kadima, and you can text me there. So back to you, Ivy.
Thank you so much, Sam, for the amazing session that you've taken us through. I hope that you've gained, okay, rather the people who joined the meeting have gained insights. For those who want to start on DevOps, at least now you know where you're gonna start from. And thank you everyone for joining the meeting. Just to clarify, the reason why we have put most people as viewers is because we had an incident before, so it's kind of like a precaution, but it's also a way of interacting. So yeah, for the next sessions, if you have questions, of course now we can allow you to use the chat section. So we'll see you guys in the next session that we are going to have. Have a good night, and thank you for joining.